Uh, so with that, again, I'm Jeff Glover with Willdan. I lead our sales, outreach, marketing across the country, in particular California. The CETA program. The CETA program is a program that provides uh, incentives for new construction projects, specifically commercial. And at the end of this presentation, we'll kind of dive into that a little bit and how you might be able to take advantage of the complementary incentives that utilities provide as part of this program. So Joanne, she's one of our support individuals within Willdan, and Sean is another outreach specialist here who covers the state of California as well. So this course has been approved by AIA. Upon successful completion of this course, reporting for AIA members will be provided along with a continuing education certificate for those who request one. And then, of course, it has been approved by GBCI for one general continuing education hour. Upon completion, lead professionals can request a certificate for self-reporting to GBCI. So here's what we're going to talk about today. First, we're going to set the stage with some key terms and concepts. Then we'll dive into the energy analysis exercise, in which we're going to take a real case study and run a few what if scenarios to evaluate different conservation strategies that should be considered. After that, we're going to reveal the built project results, and then we're going to review some of the key takeaway concepts. So that's what we've got set forth today. And as mentioned, it is a live interactive polling session. So here is the QR. I'll pause just for a few moments to let individuals scan that QR code, and then we'll give it a test run to see if it's actually working. We tried it today. It was working, so cross fingers that it continues to work. Okay, just a few more minutes here, and then we'll do our first test poll. Okay, let's see if it's working. It looks like it is. Okay, that's always good to see. It's always can be a crapshoot sometimes. Okay, let's continue. So let's talk about why is energy efficiency important? And how do we get to that clean, cost-effective energy future? We all know that reducing the energy consumption of the built environment is vital to success. But as design professionals, we have an important role to play in cutting consumption. So is it as easy as adding solar to every rooftop? Unfortunately, adding renewable energy generation without first implementing some energy conservation measures can actually have detrimental effects to the grid, which is why we kind of need to exercise our creative problem solving skills in order to reduce the actual load of the building as much as possible. So we're going to do our poll question. Typically, what do you utilize to help make decisions with regards to energy efficiency? Is it rules of thumb? Do you rely on manufacturer's literature? Maybe you're comparing other buildings, or do you, in fact, at this moment, do you actually use an energy model? All right. So far, so good. Good to see. Well, this is the right presentation for you then. Perfect. Okay, so while we're at it, we're going to do another poll. So maybe what types of projects do you think tend to implement more energy efficiency measures? Multifamily, institutional retail. what type of buildings may implement, again, the more energy efficiency measures into their projects? Kind of a tricky question, as there's really no rules to follow in terms of the type of project. It very much depends on, you know, building type, budget the owner has. Um, it is, however, somewhat of a trend that we see. More institutional buildings tend to implement energy efficiency measures since they're actually least interested in the shorter paybacks. Yep, that's kind of in line with what we see. Okay, great. Thanks for participating. Um, so in our discussion today, we're going to be talking a lot about EUI, and maybe for those of you that aren't as familiar with it, EUI is a key metric to understand basically how buildings use energy. It's measured in kBTUs per square foot per year. You can consider it similar to miles per gallon in a car, but in this case, we actually want the lowest number possible. So how does that work? Basically, we're going to take all the energy needs in a project, the heating, cooling, lighting, think, anything that makes your meter spin, and divide that energy consumption by the square footage of the building. Now, this is going to help normalize the value independent of the size of a project. So then we can compare, the efficiency of a smaller building to say that of a larger building on a per square foot basis. And of course, the resulting number will in fact be the EUI. Now, you might be familiar with the difference between site EUI, which looks specifically at on-site energy consumption, and source EUI, which also takes into account efficiencies in generation and transmission. But for today, we're going to keep it simple, and we're just looking at on-site energy. Just know that if you're involved in any energy studies and comparing different projects or results, that you know which EUI you're using. That way, you're keeping your comparison as apples to apples. Okay, so how do we get to that clean, cost-effective energy future? It's hard to say, but again, it's critical, to reduce the energy consumption of the built environment is very vital to our success. And again, as design professionals, we all play an important role in cutting that consumption. And again, not as easy as just putting solar on every rooftop. And we'll jump into that a little more here as we go. Well, so far we talked about energy in the big picture and on the grid and at the site. So now we're going to move into the building and talk about efficiency. So as an example, here are a few energy efficiency strategies you might consider. And then again, here are some more and some more. And yeah, as you can see, pretty soon we're overwhelmed and we really don't know where to start. So how can you cut through, all that and see what makes sense for your project? So let's build on some structure and try to find the right strategies for our project. One place to start is to know what your goals are. You're trying to reduce costs for your client. Do you have a lead, maybe a lead goal, or you're trying to get to net zero? Each one of these goals can send you down a very different path with your design. So the first step, obviously, is to know what your goals are. So now that you've identified your goals, it's time to strategize. But again, how do we choose the right strategies? We did a poll on this earlier. Oftentimes, teams will depend on rules of thumb, literature, comparing buildings. Well, as you can see, this is going down a rabbit hole of basically endless possibilities. So luckily, we can help you out of that hole and instead leverage energy models to really do some of the heavy lifting, some of that heavy lifting, that heavy work for us. When utilizing rules of thumb or manufacturer's literature and comparing EUIs of other buildings to your design, it's important that you compare apples to apples. And here are some variables to consider to ensure that you're in fact doing so. Now, one example of this is our team had compared two project locations from the same large retail chain. The building layouts were identical, with the only difference being the buildings were actually reoriented by about 45 degrees. It was very surprising to see how different the energy usage results were, as you would think that both locations would have the same results, and since both buildings had similar footprints and the same operations. However, due to the orientation of one of the buildings and the window placement, more energy was being used due to the heat gain from the sun, and as a result, the energy savings and the utility incentive were in fact much lower. So unless cost is no object and you're not trying to get to the best, most efficient building out there, you're trying to balance those first costs and savings against your goal. And we're trying to find that quote unquote that sweet spot with the group of energy conservation strategies that's basically going to give us the biggest bang for your buck. And that's what utilizing, as you know, utilizing energy modeling is going to help identify that sweet spot. Now, we've got the greatest opportunity to maximize our savings by starting in schematic design and design development. First by minimizing the energy load through efficient massing, judicious use of glazing, followed by the implementing simple, cost-effective systems in design development. Now, doing this is going to help minimize your base load and allow for any renewable energy sources to be implemented at a much more cost-effective rate with less impact to the grid. So what goes into a comparative analysis? You've got your building geometry, hours of operation, assumptions on how a building is operated and occupied, an average weather file. These minimum requirements set the baseline that we're going to compare against. And again, all these factors together are going to equal the results of our energy model. But with everything that goes into these models, it's important to remember that combining the effects of energy efficiency strategies isn't always straight addition. In this case, 2 plus 2 doesn't always equal 4. That's because we it's a whole building analysis and a whole systems approach. We then need to factor, how these strategies are going to interact with each other. A simple example of this is, using LED lighting, which obviously generates less heat, which in turn reduces the cooling loads in the summer, but it's going to increase the heating loads in the winter. Since those loads aren't perfectly balanced, then the net result is somewhere in between. And it's going to take a comprehensive energy model to help identify how that's going to play out. So for the purposes of our discussion today, we're gonna narrow our energy model down to 6 categories to review, and here they are. So we're going to be looking at building massing, envelope upgrades, lighting controls, HVA system, demand controls, and energy recovery. Okay, so a little bit about the project we're going to look at. We purposely chose a project not in California, so you can't cheat on the tests we're going to give you here shortly. So again, it's based on an actual project that came through our Des Moines office, elementary school, typical programming, normal uses, typical hours of operation. Keeping in mind, only parts of the school are going to be occupied during the summer months. Again, this project is located in the heart of the Midwest. So basically think really, really cold winters, hot summers, and basically all too short spring and fall. So we're actually gonna give you a pop quiz here shortly. It's day one of your project. Your owner comes to you and says, "What should we do?" So no background here. We're just looking for your gut reaction on maybe which combination of strategies shown might add up to an efficient project. So on your phones, you may have to refresh them. On your phones, you can key in A, B, C, or D, depending on which combination of strategies on the left might have the most impact. Now, we're going to give you some more details on this later and see how that might change your answer. But for now, simply give us your best educated guess. Great. Yeah, and some of your phones may have timed out and you have to hit refresh, unfortunately. Great. Okay, great. Thanks for submitting your votes. Let's keep going here. So now let's think back to those six energy efficiency conservation measures we talked about a few minutes ago. So right now we're gonna actually walk through each one of those strategies. We're gonna review the options you'll have on the table. We're gonna talk about some of the energy data you'll use to inform your decisions. Then we'll let you select which option you'd like to use in each category. But not all energy efficiency strategies cost the same, and we all know that every project has budget constraints, so we'll need to keep that in mind. We'll show each option with its related cost in dollar signs. And to simplify this exercise, we're just going to say we've got $12 to spend on our energy efficiency upgrades. So let's dive into some of the what we'll be looking at. So first, we're going to look at building massing. So on the left is the base option. You know, this is a floor plan focused on views, daylight access, visual interest for the occupants. The alternate on the right has the same square footage, the same program, but it's more compact. You know, has fewer windows and of course costs less to construct. Now, now each option does have its benefit. You know, this first option may be better for user experience, could save money on lighting if daylighting controls are factored into the design, but we'll have more, you know, it's going to have more heat transfer. So the HVAC system is going to have to work harder than if the compact form was implemented. So that is a look at our building massing. Next, we'll be looking at the makeup of the envelope. Are we using fairly basic insulation and glass on the left, or are we upgrading, perhaps adding, you know, a layer of continuous insulation on the walls, cutting down on some of the thermal breaks, thicker insulation in the roof. You know, paired with that, we're looking at reduced solar heat gain glazing to cut down on the cooling loads. But as we know, designing for you know, increased insulation and adding more efficient windows can be expensive. So the upgraded option here is twice as expensive as the base option. Next, we've got our lighting controls. In the base buildings, we have standard occupancy and vacancy sensor lighting controls in areas where those, you know, those type of controls make sense. With our upgrade, we still have the occupancy controls, but we add daylighting controls that's going to, you know, dim or turn off the light fixtures when we have enough sunlight to meet our needs. You know, it's not super expensive, but the amount of daylight that you'll get, you know, very much depends on the building, the building massing that we decide to go with. Here's where we're going to jump into the mechanicals. Our base design starts with a pretty typical, you know, VAV system with a gas boiler and air-cooled chiller. Our upgrade, we're going to move to a ground source heat pump system, as you know, referred to as geothermal, where we push and pull heat energy into and out of the earth, providing you know, heating and cooling for the building. To install, oops, sorry, something just went haywire with my system. So to install a geothermal system, you'll need to drill many wells in the ground, which can get expensive up front. So the cost is going to be a lot higher than your base system. Next, we've got our HVAC demand controls. In our base design on the left, we have typical controls responding to the needs of various spaces based on temperature and maybe humidity. With our upgrade, we're going to add demand controls, which allows us to cut back on ventilation rates and possibly setback temperatures based on whether spaces are actively being used or not. Now, this could take the form of carbon dioxide sensors that kick in when high occupant loads drive higher CO2 levels, or occupancy sensors to detect movement. Now, this is a fairly low cost upgrade, especially with occupancy sensors, because we can actually tie into the same sensors that are being used for the lighting controls. And last but not least, we have energy recovery. And very simply, in the base design, we don't have it, and in the upgrade, we do. In this case, we're providing total heat recovery, capturing both the sensible and latent heat energy, or in other words, the heat in the air and the heat in the moisture in the air that would have otherwise been wasted through the building's exhaust air. So now that we understand the differences in strategies, it's time to once again pick your strategies. We also included, the savings ranges, which are actual results from an energy model for this particular building, to help you make a more informed decision. Now, the ranges are based on what other strategies are also being selected. So some strategies perform better only if they're paired with other specific ones. All of these combinations are going to meet our first cost budget of $12. And again, we're looking here how to achieve the best energy cost savings. If we were looking at EUI savings, the savings range would look very different, and on a different strategy combination would win. Once more, I want to know if this was a different building type and a different location, the savings here would look entirely different. Okay, let's see what comes in. Pause just a few more moments here. Okay, let's keep going. All right, let's take a look and see how we did. So we're going to walk through each option and look at the results. So for option A went with the compact massing, the envelope upgrades, the daylighting controls, decided to go with the VAV system, demand controls, but opted for no energy recovery. So let's see how option A fared. Okay, not great. So 19th out of the 32 possible combinations in this exercise. So, EUI is not great. They are actually, though, saving close to $50,000 saved annually in the utility spend. So that's option A. Again, 19th out of the 32 options. Not great. But let's take a look at option B.
Hey, Jeff, we had a quick question in the
Oh,
chat.
okay, sure. Let's see, where is that chat?
Um, so is the savings range calculated by initial cost to construct plus ongoing operating cost minus energy savings?
I gotta think about that. Yes, it is. Yep, correct. Hopefully that's yes. I had to think about that a minute. Yes, it is.
Thanks.
Yes. Okay, let's see. Option B. So option B, compact massing again. They went with the upgrades as well. Decide on the basic lighting controls. For VAV, I'm sorry, for the HVAC system, went with the VAV. No demand controls, but did decide on the energy recovery. All right, let's see how B fared. It jumped up. So in the top 10, you can see the EUI uh, improved, and so did the annual savings. So B's not a bad option. All right, let's take a look at C. C, again, went with the compact massing, decided on the basic envelope, basic lighting, opted for the geothermal, no demand controls, incorporated the energy recovery. Let's see here. Okay, that was in fact the number one option of the 32 that were given. Tractive EUI 32, and getting getting up there on the annual utility save. So C was in fact the correct choice. But for the sake of doing so, let's take a look at option D. So D, decide on larger massing, the basic envelope, daylighting controls, the VAV system, demand controls, however, no energy recovery. Let's see how D fared. Yeah, not great. 27th, 32, not a very good EUI. Although again, they're still saving a fair amount with their annual against their annual utility spend. But yeah, D was not a good option.
We had another quick question about what the EUI range was again.
Oh, I don't know if I'm trying to think the range. Sorry, I don't know if we have that in the presentation. My apologies. I don't know if we put that in there. I'll have to get that for you. Sorry about that. Let's take a look at how all the different energy strategy combinations fared and maybe some trends on how specific strategies played into the overall results. And Kelsey, thank you for letting me know there's questions. Unfortunately, I can't see the questions as I'm presenting here. Um, so this is a graph of every possible outcome in this exercise. Each bar here represents the savings resulting from one combination of strategies, and in total, uh, there are 32 combinations of strategies that we looked at that stayed within our budget. And if we stack them up in order, least savings on the left, most savings on the right, we can see that by selecting strategies within our budget, we can potentially save the owner around $60,000 a year, which for this building would mean a 40% reduction in their energy bills. Now, remember, we want more savings, meaning lower energy costs. So let's take a look at some of the strategies here. So the dispersed form strategy is included in two of the lowest energy savings design, but is also included in some of the higher saving groups. The savings you here see are basically heavily tied to which mechanical system you decide to implement, because the heat loss and the heat gain are in fact much higher. The ground source heat pump system savings may seem a little surprising. We always think of geothermal as being the best system that you can implement. So you may think it be, would have the highest energy cost savings but these kind of fall in the middle-ish of the group, which is, mainly because the cost of natural gas is relatively cheap right now. And this option switches from gas to electric heating. If the cost of natural gas goes up and the cost of electricity starts to go down, this grouping would change significantly. And of course, if we were looking at EUI instead of cost savings, these groups would be among the highest on the chart. HVAC demand controls are included in groups across the board. So it leads us to believe that for this particular building, it just really isn't a huge driver of energy savings. But speaking of drivers, the energy recovery combinations are the top nine. Has a lot to do with the climate zone where this project is located. As in Iowa, very cold winters, hot summers. We need to be able to capture as much of that waste heat and waste cooling that we can. Envelope upgrades are important, but also expensive. And in order to include it in the design, often we just didn't have the budget to upgrade it. However, when we're able to afford it, along with the energy recovery strategy, it did in fact add up to the highest savings combination. And like demand control ventilation, lighting controls are all over the place, which tells us again, not a huge energy savings driver, but since they're, it's a relatively inexpensive measure to implement. So, it is easier to fit them into the designs, and it could really be some of that low-hanging fruit that we can take advantage of. And then when you do have a lower budget, you would typically think that that means you won't be able to save as much energy, which is generally true, except you can use the energy model to develop a scenario where you can actually have significantly more savings if you look at different options outside of what you may have normally thought of. And of course, the cost of energy efficiency measures can affect the project budget, obviously. But an energy model can help identify the most cost-effective group of energy efficiency measures. And here, the relative costs are overlaid on the measure combinations. So overall, for this particular project, costs trended upward as efficiency improved. But as you can see, it wasn't linear. In some sections of the chart, costs actually trended downward as efficiency improved. So if you're working within a budget range, an energy model, it's going to really kind of help you find, as we mentioned earlier, find that sweet spot of lower costs and higher efficiency. So let's go back to what did they actually construct for their building? So let's take a look what the actual team ended up doing. But first, let's remember, the optimal time to maximize on savings is again during that schematics and design development time frame. First, by taking the steps to minimize the energy load, then followed by the implementation of simple, cost-effective systems. All right, so now let's take a look at the what they chose. So the real life team actually went with option D. And if you remember, that was the worst option. So they did not heed our consulting. They did not, they knew what they wanted and they went with it. So let's take a look at what they did. So they went to, disperse form, basic envelope, daylighting controls, VAV system, demand controls, and opted against the energy recovery system. The reason they did that, they were actually worried about the maintenance concerns from the energy recovery system. So they opted against it. And again, we see how this project's design played out. Not great on both cost savings and EUI, although they did fairly well with the peak savings. But overall, as we learned, uh, there's still a lot more potential for this particular project, as we saw. Now, eventually, they did take some of our advice. The school decided to switch from the VAV system to the geothermal heat pump system. It just took some time for the facilities director to get comfortable, learning a new system. Um, and we should note that by making this upgrade, the school spent additional funds and in fact did exceed their budget. But in terms of performance, the geothermal upgrade shifted the school up to 15th place, and the energy cost savings improved, and the EUI also improved dramatically. So after construction, we were able to look at their meter data and compare the actual energy use shown here in green to what was originally modeled, shown here in blue. So why was the actual energy use higher? Now, there's a couple reasons for this. We had originally anticipated the hours of operation to be less during the summer due to school being out, but it turns out the community liked having this fresh new building, and they wound up using it a lot more during the summer months for various events. Another factor for the increase use was they had actually disabled all the daylighting controls after they got a complaint from one of the teachers who indicated the lights weren't working correctly. So the good news is that after that was realized, the controls were recalibrated and they were uh, able to start using those controls once again. So if you have learned that the energy use of your project has changed, there's no reason to panic. Some common reasons we found as to why the meter might be different from the model. Hours of operation or hours of use have changed. Space might be being used differently than expected. Maybe didn't anticipate higher plug loads. Controls have been overridden, or the calibration is off, or there's an equipment malfunction. Now, this is rare, but it does in fact sometimes happen. So as we're wrapping up here, here are some key takeaways when evaluating a project's energy potential. With every project being different, it's important to establish those energy goals early in design, especially when utilizing model data to support your design decisions. And partnering with your electric provider, it helps you take advantage of complementary consulting services and incentives that are available for projects. And we'll touch on that here in a moment. So remember that, as you're diving into your projects, there is complementary help and money available that we can throw at these projects. But then again, it's key to remember that people are going to run these buildings uh, very differently than we would ever expect. So a quote we want to leave you with today, a good reminder that energy use is a challenge that's in the hands of various project teams, and there's tools available to help solve it. So that concludes actually the certified AIA portion of this presentation. I'm going to due to time, I want to slide into how you can actually take advantage of what I mentioned earlier, the complementary energy modeling that's available for you. It's called CETA. That's the program that Willdan manages in the state of California. It's a utility program. It's no charge. We're desperately trying to give away funds to help implement some of these aggressive strategies for energy efficiency. So if you have projects, we'd love to hear about them. We'd love to get them enrolled in the CETA program. We as Willdan, we don't we don't replace anybody on the team. We're a collaborator. We share ideas. How can we make these buildings more efficient? So that's our goal. So what is CETA? California Energy Design Assistant. It's basically a statewide utility incentive program for new construction and major renovations. We're trying to help promote electrification, decarbonization. Again, we work in collaboration with project teams in an effort to help, reduce energy demand, consumption, and trying to, reduce those carbon emissions. The CETA program serves a whole host of building types, commercial, public, high-rise multifamily, industrial, agricultural projects that reside or within the areas of Pacific or PG&E, SoCal Edison, SoCal Gas, and San Diego Gas and Electric. So those are the service areas where CETA is offered. So why participate in this program? So again, you're going to receive complimentary decarbonization analysis tailored to your project goals, and we're going to try to help identify the most effective measures to implement into your project. You're going to gain analysis of both the energy costs and the paybacks. If there's a measure that doesn't make sense, if the ROI is many years, we're going to recommend not implementing it. Again, we're trying to help find that sweet spot of maximum sustainability and what the budget can allow. That's the goal of the CETA program. Obviously you're going to help or receive financial incentives again to help offset the cost of those decarbonization measures. Um, and if your design, we're gonna reward you for demonstrating a commitment to maybe implementing some high performance building practices into the project and into the design. So if you're on a design team, if you're an engineer, an architect on the call, um, we do. There's two incentives that are paid, one to the building owner or developer, and then we also give you a flat fee, a 2,800 design team incentive for participating. However, we right now from it started September 1st to the end of the year. If you bring us a project, and you're on the design team, it's been bumped up to $5,000 per project. So again, two payments, one to the developer owner for what the building achieves, but then you on the design team, you're going to get a flat $5,000 for your participation. Now, again, CETA's goals, we're trying to exceed California's, strict, aggressive decarbonization standards by trying to identify, some of the high performance measures and providing educational opportunities to explore use cases and best practices. This is going to help advance the market, but also qualifies participants for enhanced incentives through our program. So again, we're going to reward if you've got some very, again, we call them high performance measures. We're going to identify those and again, incentivize for having those um, within your project. If you'd like more information, scan the QR or you can contact Sean. Again, Sean helps represent the California market. Um, but yeah, we like I say, we're desperately trying to give away funds to help advance the decarbonization goals of California, and we'd love to hear more about your projects. So with that, that concludes our presentation. And I see now I can see now I can see the chat. Unfortunately, no CETA for LADWP. Unfortunately, we're working on them. We're trying to get them to come over um, and join up with CETA. So yes, we hope within a short amount of time we get LADWP to join us as well. So, but with that, I appreciate everybody's listening and participation today, and hopefully you've got some projects we'd love to hear about them.
Okay. Well, thank you, Jeff.
You bet.
I'm going to open up the floor now to any Q&A from the audience. If they'd like to ask Jeff any questions, we can do so now.
Now, if I mentioned it, our I'm reading it quick. Can existing buildings upgrade to power over? Yeah, that honestly, I don't know. That's a great question. I'd have to ask one of our energy specialists or energy modelers or project managers. That's a Wes. I'll try to find out and get back to you. Great question. But I didn't mention earlier in the presentation, we do prefer projects if they come to us that they're in early in design. Schematic design development is our preference. That way we can try to maximize the incentive, maximize savings. If they do come to us at when in construction documents or have started construction, we'll still take a look at them and basically look at what you've put into the design and at least reward you for what you have what you've already implemented into the design. But our preference is earlier the better. That way we can maximize savings. What platform we use? We have I don't know if this answers your question. We have a proprietary platform that we've created that we use for our modeling. It's called Neo. And when you enroll your projects, Neo allows us to do basically it's a live charrette where we can um, in real time take a look at various options to consider. You may say, let's use this this type of cooling tower efficiency with this lighting, with this insulation, and we'll change up the options. And Neo, our software, um, will in fact it's real time. It'll update both the incentive and the year over year energy use of the building right then and there. So we're able to make decisions on the fly with Neo because it provides real time data. So it's basically when you enroll the program, it's a live charrette. So yeah, your platform you use is called it's proprietary. It's called Neo. Well, great. thank you for the questions. Kaylin, uh, thank you for letting us be a part of this presentation today.
Absolutely, and thank you. Thanks to our presenter.
Great. Have a great Friday, everybody. Enjoy your weekends.